Hello there and welcome back to sixth part of this coordinate geometry. This is Sachin sir and we are solving problem set. Here we go with the 12th question on the board. The question says that we need to prove this quadrilateral PQRS as a rectangle. An action plan for this proof is nothing but we are going to solve 4 sides and 2 diagonals by distance formula. If we find that opposite sides are equal by using distance formula and the length of diagonal are also equal, then we can say this quadrilateral is a rectangle. So in short, we are going to use distance formula. We are going to find 6 sides in all, including 2 diagonals, and if we find that opposite sides are equal in length along with the diagonals, we can say PQRS is a rectangle. Here we go with the solution. So boys and girls, as we know our action plan, let's begin with finding the side PQ by using distance formula. Here is a PQ. We know the formula x2 minus x1 the whole square plus y2 minus y1 the whole square. Observe the coordinates given in the question very carefully. Substitute them in the formula. After carrying out the operation by using integers rule, you will get the value at the final root 13. Similarly, when you apply the formula and substitute the value for the other sides, you can find their length by using distance formula too, the way you are looking on the screen. This will be the value you will find after you applying distance formula. If we observe the final answers now, in 1 and 3 we can say PQ and RS are equal, and by 2 and 4 we can say QR and PS are equal in their measures. Now time to find diagonal the way we decided. Now here PR diagonal equals to root 65, same after using distance formula. Similarly, find the diagonal QS, and to your surprise you will find same value of QS after using distance formula. So by 5 and 6 we can say diagonals are also equal. So as a result, while writing the final answer, you have to conclude properly. So mention it with reason. By 1 and 3 we can say PQ equal to RS. By 2 and 4 we can say QR equal to PS. And by 5 and 6 we can say diagonal PR is equal to QS. So in this way, as opposite sides are equal, diagonals are equal, so point PQRS is going to form a rectangle, and in this way we have proved it. Students, this is the 13th question on the board. The question says that I need to find the length of all medians in the triangle ABC. The vertices are given with their coordinate. Very first, what is the meaning of median? Median is a segment that joins vertex to the midpoint of the opposite side. So we need to find the length of that segment by using distance formula. But before that, we need to find the midpoint of the opposite side, and those coordinates will help us in the distance formula. So very first, my target is to find the coordinates of the midpoints, and then I will find the length of medians. So here we go with the solution. So as per requirement of the question, consider triangle. These are the midpoints DEF, and when you join these points with the vertices, we get the medians as AE, BF and CD. Now my target is to find the coordinates of these DEF by using midpoint formula. For D, I am going to utilize values of coordinates given for point A and B. For E, I will use the coordinates of B and C. Keep it in mind. The moment you substitute the values of coordinates from A and B, you get the answer x equal to 2 and y equals to -1 for point D. In short, we have D equals to 2, -1. The moment you substitute the values for point E from the coordinates BC, we get the answer 4 and 1. Now similarly find the values for point F, by which we can get their coordinates respectively, and my answer comes F equals to 1 and 3. While after substituting the values, do not forget to use the rules of integer while carrying out the operation without fail. And while substituting the values, please check twice whether the sign given in the question is properly utilized or not. After finding the values for the midpoint DF, now I will find the value of length for the median AE, BF and CD by using distance formula. According to formula, we have to subtract x2 and x1 and then square it, and similarly subtract y2 and y1 and square it, and after the addition we get the answer 5, right? Because 5 square is 25 and that gives me the answer 5. Similarly, find the values for BF and CD also by utilizing distance formula. Substitute the values properly and you will find that you will get the answer 5, root 68 and root 37. From this, root 37 and 5 are the final answer. But for 68, you can turn it into 13 4 the 68, and that 4 in the root can be moved out as 2 outside the root. So in short, we have the values of AE as 5, BF as 2 root 13 and CD as under root 37. Since this is the 14th question on the board, question says that I need to find the coordinates of centroid and coordinates of midpoints of every side of the triangle are given to us. What I'm going to do, I'm going to join those midpoints. That will give us new triangle, right? And to our surprise, the centroid of this new triangle will be same as that of centroid of the main triangle given to us. For better understanding, let's begin with this diagram and all. To understand the question more properly, consider a triangle. Let A be the centroid of the triangle and these are the midpoints of the side DEF. Now if you join these midpoints, we get a new triangle, and for our surprise, this centroid of the main triangle also acts as centroid for this newly formed triangle with the help of midpoints of those sides. So we can say point A is centroid for triangle DEF also. And now I can find the coordinates of centroid by using centroid formula simply. Okay. So first of all, let the coordinates be x and y, and now by using centroid formula we know we have to add all the x coordinates of point DEF, that is minus 7 plus 2 and plus 8, and divide them by 3. We get the answer as x equal to 1. Similarly, to find the y coordinate, I'm gonna add all the y coordinates of the points given and then divide them by 3. As a result, we get 9 upon 3, resulting into the answer 3. And so we can say the coordinates of centroid A are nothing but 1 and 3. Easy peasy, right? This is 15th question on the board. I need to prove ABCD are the vertices of a square. For this purpose, again I'm going to use distance formula. I'm going to find 4 sides and 2 diagonals. If 4 sides are equal in length and 2 diagonals are also equal in length, then we can say these coordinates make a square. So let's begin. So as per our plan, I'm going to find the values of side AB, BC, CD and AD by distance formula. Let's begin with side AB. The moment you substitute the values, do not forget to give the sign of the coordinate very carefully. After substituting the values, carry out the operation by using integers rule and you will get the answer root 5. The moment you apply the formula, substitute the values for other side like BC, CD and AD, you will come to know that the values, the final answer you will get is root 5 for all 4 sides. And that's why we can say all these sides are equal in measure. Now it is time to calculate the values for diagonals. Formula for the distance is x2 minus x1 the whole square plus y2 minus y1 the whole square. Please check the values twice from the coordinates given and then substitute them in the answer. For BD, after substituting the values, we will get the answer root 10, and for AC, again you will get the answer root 10. So by 5 and 6 we can say the diagonals are equal. So in short, according to our observation, by 1, 2, 3, 4 we can say all sides are equal, that is AB, BC, CD and AD. By 5 and 6, diagonal BD and AC are also equal, and so as all sides and diagonals are equal in length, we can say point ABCD can form a square. Isn't it easy peasy? Yes. Students, this is the 18th question of the problem set. The question says 4 points are again given to us and I need to prove what type of quadrilateral are these points gonna make if they joined serially. Same thing, 4 sides will be AB, BC, CD and AD. I'm gonna find their length by using distance formula, and by observing their length we have to decide what type of quadrilateral is made by these coordinates. So let's begin. Again, as we have decided, we will find the sides of this quadrilateral. Side will be AB, BC, CD and AD, and then we'll see what relation we can find the length of this side. So again, to find these sides, we will be utilizing distance formula. According to distance formula, the length of AB can be calculated as root 26. For BC, the moment you substitute the value, you will get the value as root 61. For CD, you will get the answer root 26, and for AD, you will get the answer under root 61. Boys and girls, again I am telling you, while substituting the values, please be very careful about the sign, and do not forget to use rules of integer each time whenever you operate them. The square of negative number is always positive, keep it in mind, and the moment you apply the rules of integers while adding or subtracting, please use bigger number sign for the answer. So let's move on. So by observing 1, 2, 3, 4, we can say that by 1 and 3, side AB and CD are equal. By 2 and 4, side BC and AD are equal. So these are nothing but the opposite sides, and when we have opposite sides equal, then that quadrilateral can be called as parallelogram. So we can say point ABCD are the vertices of parallelogram, and that's it.